Thank you. It's good to be here with you today. My name is Matt Jones. I'm a staff software engineer for a company called Automox, where I help lead the front-end development on the team. I've been working in front-end development for the last 20 years. I built my first website about 20 years ago using Microsoft FrontPage, for those who remember. And been using Vue for the past 6 or 7 years, but this is my first Vue conference, so I'm excited to be here with you today. I'd like to begin by briefly explaining what a micro-frontend is and address some of the misconceptions that I've heard about what they are and how they work. And we're going to do that by showing some examples. So micro-frontends, they come in many different shapes and sizes, but ultimately a micro-frontend is just a pattern for building a single application from multiple independent components. They can be developed, tested, and deployed independently. Micro-frontends bring the microservices approach, though they're quite different, to front-end development, and they enable breaking down large applications into smaller, more manageable pieces, each with their own independent and isolated pipelines. So to get into the examples, this is the first one. This is the tractor store example from microfrontends.org. If you've looked into microfrontends, this is sort of like the hello world example that you'll see. And I like this example because it shows how separate microfrontends can be loaded at runtime within a single application. Here we have a host application, the team product red application, and we have two others, the checkout and inspire. And each one can be worked on, built, and deployed independently, but at runtime, the host application can load the checkout or the inspire application as needed. So here's another example that I wanted to include. I'm sure we're all familiar with services like these, like Intercom. Intercom provides these chat widgets. And to display the chat widget on your website, they provide you with a few lines of code that usually includes a JavaScript file. And that file is requested at runtime on your website. It's a micro-frontend application that gets embedded, and they usually use that JavaScript file to display an iframe, embed some styles, some HTML to your page. They can deploy changes to that JavaScript file whenever they want, and your users will immediately see the updated chat widget. You don't need to do anything for Intercom to change their micro-frontend application. These embedded Twitter posts, YouTube videos, these buttons from GitHub, they're all examples of embedded micro-frontend applications. And I think we're all familiar with these. But you don't need to have an embedded application in order to use micro-frontends. So this is an example similar to the tractor store where we have a single-page application. And these micro-frontends that can exist on the website, they don't need to be reusable pieces. They don't need to be shared across third-party apps. Here, Spotify used a micro-frontend approach where the web player was its own application. It was included via an iframe, and then it could talk to other parts of the application through custom events and other services. And with this approach, one team could be fully dedicated to the web player here in yellow. Another team could work on the discoverability and recommendations in red. They could have their own back-end services that they talk to. And all of this can be brought together nicely within a single application. So what we've seen in the tractor store example and with Spotify is a horizontally split micro-frontend architecture where multiple apps are running within a single page. But another approach when building micro-frontends would be to use a vertically split pattern, where apps are divided by a URL path or domain. With a vertically split approach, everything within, in this example, our /dashboard URL would be a single application. And if I navigate to reports, I'm navigating to an entirely separate application. The idea behind these examples is to show that there are lots of ways to split apart an application, lots of ways to do micro-frontends. But why would you want to split the app at all? What's the use case for using a micro-frontend architecture? So I want to try and paint a little bit of a picture here. In the early days of a Vue application, everything is nice. I think it's super fun spinning up a new Vue app, whether you're doing it by yourself in a small team or even at a large organization. those early stages are often fairly similar. You create a Git repo, you install your initial dependencies, you set up some simple prototyping, and everything's great. The world is a pretty peaceful place at first. Everything is right where you want it. It's simple. You know where everything is because you or a small team likely wrote it very recently. But soon enough, a common thing happens among app developers, and that is we release apps. And when we do, this kind of terrible thing happens. We get users. It's not really terrible, but those users end up wanting things. They want features. They want new settings, new capabilities. And as the app grows, often our companies grow. And when our companies grow, we add new team members. And at this point, some of the things that weren't important early on in a Vue application suddenly become pretty important. We need to set up pipelines. We need to set up processes so that systems don't get bogged down and it becomes too difficult to work on the application. After a while, as teams grow, there can be new features and new parts of the code base that you're not even familiar with. And in the real world, the challenges that come from a growing team and a growing app can be solved, in time. But a monolith, which can at the beginning seem like a very reasonable and practical approach, can quickly start to stifle development and slow you down in large code bases and with large engineering teams. So this is where we found ourselves and where many teams find ourselves kind of caught between demands of product and an ever-growing code base and an engineering team that wants to move quickly. So one thing I want to make clear is that deciding to go with a micro-frontend architecture is largely about scaling development, not scaling performance. It's not about optimizing our app for speed or about being able to support multiple frameworks like Vue, React, Angular all at once. While those are possibilities in a micro-frontend architecture, it's much more about scaling development and increasing developer productivity as our teams and applications grow in both size and complexity. But why is this important? I'm going to take a big risk saying this to this crowd, but it's important because while you and I may think otherwise, software engineers make mistakes. And I'll stand by this statement. You can quote me on this. However, I think a more uplifting quote is this one that I first heard from Multi of Vercel, so I'll attribute it to him, that iteration velocity solves all known problems. Despite the fact that we do make mistakes occasionally, the faster we can iterate and the quicker we can solve problems, adapt, and learn, the quicker we'll be able to make our users happy and build applications that we love to work on. And using micro-frontends is simply a tool to empower teams to iterate quickly. So if developer productivity and iteration velocity can solve all of our problems, how exactly do micro-frontends help us? In my experience, micro-frontends have helped our team, and I've seen other teams, move quickly by allowing them to have greater team autonomy, smaller, independently released features, decoupled, resilient software, and the ability to make system-wide upgrades iteratively. So very quickly, I want to go over some of these. The first is that micro-frontends give your teams clear boundaries, clear ownership so that everybody knows what their responsibilities are. With clear boundaries, each team can play to their strengths. Decisions can be made to use certain technologies or processes that allow your team to work faster or allow your app to do things that maybe the system-wide or other applications don't need. There's less cognitive load required for engineers on a single team because working in a smaller, self-contained chunk of code will just inherently be easier to understand and quicker to debug. Lastly, micro-frontends allow dedicated teams to understand their domain deeply. And when you know your code deeply, you can usually pinpoint exactly where problems are as they arise a lot faster. Next, with micro-frontends, there's this practical benefit of isolating teams from pipeline failures elsewhere in the app. You don't get bogged down because someone broke something somewhere unrelated and it's blocking the pipeline. With micro-frontends, these kinds of bottlenecks, they're minimized. They don't go away completely, but they're minimized. and you're less likely to introduce some system-wide failure. More importantly, each app can test, build, and deploy smaller pipelines on their own schedule. Because of this independence, releases can happen more frequently, and more frequent releases lead to faster feedback loops and makes sure that you're delivering value to users. All of this leads to building software that's more resilient. So resiliency is not defined by being perfect. It's the ability to recover quickly. And by having these smaller pipelines with smaller releases, our teams can recover much more quickly. And it's important to catch errors before they hit production, but it's equally important to have systems in place that enable us to quickly resolve those problems. So lastly, I want to talk about building software iteratively. How many of you have been through Vue 2 to Vue 3 migration? A lot, yeah. And for us, it was incredibly helpful to have all of the documentation and migration guides from Vue and the community of Vue dependencies. But even still, it was a big undertaking. And for us, it resulted in a large PR, lots of work. Meanwhile, other work is happening on the side that had to get merged in from time to time. And it became quite a hassle to upgrade all of Vue and its dependencies within a single monolith. But whether you're upgrading Vue or maybe a component library used across your micro-frontends or some other package, with a micro-frontend architecture, you can upgrade things iteratively, one at a time. They can be on different versions and have different dependencies, and it makes the process a lot smoother. So in theory, micro-frontends can help us iterate quickly because of all the reasons we've just discussed. But one thing that was important for us was to figure out how can we actually measure if a micro-frontend is actually improving our developer productivity. So one thing I want to discuss today is these DORA metrics. Some of you may be familiar with these, but DORA stands for DevOps Research and Assessment. And it's a research program, I think it's backed by Google, that outlines a set of 4 key metrics that can be used to measure the performance of engineering teams. So these metrics help us understand how quickly and reliably we're delivering code to production. Let's break these down. So first one is deployment frequency. This metric is pretty straightforward. It's simply a measure of how often we're able to deploy code to production. The more frequently you're able to deploy code, the more often you're delivering value and hopefully new features to your users. Next, we have the lead time for changes. This measures how long it takes from the moment a developer commits a change to when that change actually gets deployed into production. Now, this isn't just about the time it takes to work on a commit, but it also usually includes PR feedback, running tests, pipelines. Usually there's multiple iterations. And then this third metric is the change failure rate. This is the percentage of deployments that result in a failure. In a perfect world, this would never happen, but again, software engineers make mistakes. So finally, we have time to restore service. And this measures how long it takes to recover from a failure in production. And the faster we can fix a bug or roll back or roll forward, the less time we're going to be spending restoring service. So micro-frontends can drastically improve your DORA metrics. They did for us. Everything from code reviews to deploys to rollbacks is faster, and when problems occur, they usually affect a smaller surface area. So you guys can go to dora.dev/quickcheck. They have a form you can fill out, and you can see where your organization stands today and determine if you've reached a tipping point on any of these things and see what you can do to improve your own DORA metrics. These are particularly useful when trying to communicate with maybe engineering or company leadership about why you want to make some architectural changes to your front end. So before we dive into some real applications, let's quickly go over some best practices. When implemented thoughtfully, micro-frontends can be a really powerful approach, but they definitely come with some challenges that you'll need to address head on. First, each micro-frontend should be independently developed, tested, and deployed. I think this hopefully goes without saying, but this is the biggest benefit you'll get from micro-frontends, is having these independently released smaller chunks of code that your team can work on. Next, users should feel like they're interacting with a single application, despite the fact that you have several potentially deployed. To achieve this, you can usually have a standard design system that's shared across all your micro-frontends. And we also want to invest time making sure that we aren't loading multiple dependencies across our micro-frontends, that if they share things, that can be brought from cache. And we also want to look into prefetching to avoid any like jarring transitions between some of our applications. Third, we should automate our workflows as much as possible. I think before getting into micro-frontends, it's probably a good first step to make sure your engineering team has a culture around automations and pipelines, and you feel comfortable setting those up. Lastly, micro-frontends, they do introduce some complexity. It's crucial to ensure that your architecture evolves sustainably and iteratively. Micro-frontends are not a silver bullet, but they are a trade-off. And so it's important to regularly review your architectural decisions as a team, establish a clear governance model where your architectural decisions can be made based on team input and some set of guidelines. And then lastly, track your own metrics. Use those DORA metrics. Track to make sure that your decisions are actually delivering on the promises that you hope they will. So I want to spend the rest of my time showing how to actually build some micro-frontends in Vue. We're going to discuss some of the challenges and demonstrate some solutions for building Vue micro-frontends that can scale really well. So the first demo will be a horizontally split micro-frontend application using Vue. This is a diagram of what we're going to build today. We're going to have two Vue applications. The first I'm calling a dashboard app. It will run on port 3001 and a reports app running on port 3002. Using Vite and module federation, we're going to show how to set up a horizontally split micro-frontend application where this chart component that lives in the reports app can be embedded and used at runtime within our dashboard application. So to begin with, we're going to use a monorepo file structure for our application. This also addresses the first of one of the key challenges I wanted to talk about, which is balancing consistency and team autonomy within a micro-frontend architecture. This approach, using a monorepo, allows us to have easily shareable packages between applications, global config files, and it allows us to maintain team autonomy, but also some level of consistency and tooling across the organization. We do want our teams to be independent, but we also want to share resources. In addition, any cross-cutting, system-wide changes can still be made if necessary all at once. For us, a monorepo has been a great way to maintain that balance of autonomy and consistency. And what you see here is kind of a simplified approach, but it's very effective. Next, within each application, this should look pretty standard. We have our app-specific configs and tests. This will look very straightforward, but these can extend from our configs that we have at the root. Now, to set up module federation, where we have a host application that loads a remote application at runtime, we can use Vite. In just the last month or two, actually, module federation fully is supported by Vite, which is awesome. You don't need to use Webpack or any other tool. Here we have our host applications Vite config on my right, your left. And here it defines what remote applications it's going to make available at runtime. And on the left, we have our reports Vite config file. And it needs to manually or explicitly list all of the modules that it will make available to a host application. So in this case, it is making available this chart component using the chart name, and we'll get into that a little bit more here in a second. So now, if I could switch to code. Perfect. So let's go over this. Hopefully guys see all that. We have our monorepo structure. It should look just like what we just saw. We have our 3 applications. For the purposes of this demo, we're just going to use the dashboard and the reports. But we have our VueConfig file for the reports. Here's where we define our module federation settings using the module federation package. We give a file name where Vue is going to build the file here at remote.js that our host applications can load at runtime. And we've, again, defined our chart component, given the location of it, and given it a name so that host applications can just reference this name. They don't need to know the directory structure of this application. So I have this reports app running on port 3002. We'll show just quickly what this is before we pull up the browser. You can see we're importing our chart component. It's pretty basic. It has a single prop for the title. And this is what that looks like. Running on port 3002, we have our reports app. We have a very basic chart component. And we can also see that running on port 3002, it has built this remote.js file that we can now use within our host applications. So now we're going to get back into the code and look at what that looks like from the dashboard, our host app. So within the dashboard's VueConfig file, again, we have this federation settings. And here we list out all the remotes that we're going to run at runtime. We give it a name. This is an alias that can be anything, but it's just for use within the dashboard app so I can reference my reports remote. And then we tell it this entry file, which again runs at port 3002. This is the file we were just looking at. So now this will be available, and because this is available, I can use the chart component here within the dashboard. So first thing we're going to do is go to our dashboard and open up network. I'm going to refresh, and sure enough, at runtime, we're pulling in this remote.js file from port 3002. And what that allows for is I can go into the dashboard, open up app.vue, and I'm going to comment this out for now. We can see that I can call a define async component function. This is provided just by Vue to dynamically import components, often used for like lazy loading. But I can supply a function to it that imports from my alias at remote/reports, and then the name of the module within that my reports micro-frontend that I want to bring in here within the dashboard application. And so what that allows is I can embed it into my application, call it just like it were any other component. I can pass props to it. I can pass classes or styles. And yeah, and then it shows up here on my dashboard just like any other component. So that was module federation in briefly as an example as I could explain it. But when you're doing horizontally split applications like we just saw, there's a couple important considerations to be aware of. And the first is managing the loading and the failure state of that runtime application. So because I'm importing this in at runtime, it's possible that that JavaScript file, which in this case is just sitting on a local port, but could be hosted in an S3 bucket. It could be just any publicly available JavaScript file from the internet. It could have a delay in loading, or it could fail to load altogether. So how do we handle these runtime state management challenges? So for that, I'm going to uncomment this, and we're going to do this step by step. So define async component is incredible, and it provides a handful of options that we can pass to this function instead of just simply importing the component directly. So it provides a loader function, which again is just a mimic of what's going on here. And I have added a 2-second delay just to mock what would happen if it took a while to load this JavaScript file onto the page. And during that delay, I can supply a loading component, which in this case just is pretty basic, but you can see if I save the file, come here, for 2 seconds, we're seeing the loading component, and then once that file has fully loaded, it gets replaced with the chart component from the runtime service. So again, this is just mocking a delay, but this is how you can account for the loading state of these runtime applications. In addition, we can supply an error component in the case of our runtime application being down for whatever reason. So supplied to this component is an error prop. And for the purposes of this demo, I'm just outputting the string, but I'm going to turn off my reports application. So if I come into here, and now I refresh this page, reports is down. And so when this page tries to load my reports app, you'll see that it had the 2-second loading delay, but then it's displaying our error component. And for now, I'm just outputting the error message, which is not very useful, but you could display something useful to the user, letting them know that, hey, this part of my app is down right now because whatever reason. In addition, if it's maybe just a temporary outage, define async component provides an on-error function that allows you to do smart kind of retries so that you can attempt to load this component any number of times. So in this case, we are trying to run it 3 times, and if it still can't load it, we're going to fail. Otherwise, we're going to keep retrying. And again, we can just quickly see, as long as I saved that. I did not. Come here. So it tries to load it once, twice, 3 times. We see that loading component the entire time until it finally fails, and then we get our error component. So in that way, we can handle the runtime state of our horizontally split micro-frontends. Last thing we'll probably be able to get to is talk about how can we do routing between locally split micro-frontends. So again, we've been looking at a horizontally split application, but oftentimes we have vertically split micro-frontend applications. You can think of, I don't know, Gmail, Google Drive, Calendar. They're all vertically split applications that do share a lot of the same resources. And in this case, in production, we have a website that would be, automox.com/dashboard and automox.com/reports, right? They run at the same base URL. But we want dashboard and reports to be totally separate applications. Well, how can we do that locally? In production, you can do that through Nginx routing, through API gateways. It just kind of depends on your infrastructure. But for local development, we wanted to mimic that. So we had a single port that could route all of our requests to our separate applications, even though one is running at port 3001 and another is running at port 3002. So in order to create this setup, what we've done is created a local gateway that is just an Express server. If we look in here, we have Express. It's running on port 3000, and it imports our apps.json file. And how you set this up, there's a million ways you could do it. So this is not like the one best way to do it, but it's a way to do it. And here we've defined our micro-frontend applications. We've given them each a defined path and a defined port, so that within our gateway, we can loop over the values of that apps.json file and create this proxy using the create proxy middleware function provided by this package, so that what this does looks like this ultimately, that when a user accesses /reports, we're going to proxy that request to our app running at port 3002. When they access /dashboard, we're going to proxy that request to our app running at port 3001. And just to quickly demonstrate that, we now have our gateway at port 3000, and you request to /dashboard. You'll see this is going to my dashboard application running at port 3001. If I was not running that right now, this would fail. It would say there's nothing here at this port, and then I can switch to /reports remaining on port 3000. So for local development, it makes it really nice and easy. I can mimic what it would be like in production. And if your organization has 10 vertically split micro front ends, but I only need to work on the reports app right now, then I can just spin up the gateway, spin up reports app. I don't need to have all 10 applications running at once. So yeah, that's kind of my time. But I'll just say the last thing is just to make sure that you have, if you're doing vertically split applications, a good app shell component to handle some of the global state items that are shared between these applications. There was a great talk last year by the team at Kong about building an app shell. So highly recommend you checking that out. To close, I guess I just say that this, again, is not a silver bullet. This is not going to fix all of your architectural problems. And there's many ways to do micro front ends. But for us, micro front ends have been an incredible resource to bring our pipelines much smaller and make developer productivity a lot faster. And with that, that's all I got.
Thanks so much, Matt. I have to say, the demo gods are shining on us today. I know I shouldn't jinx it, but it's been amazing. All of the live coding has been, it's spectacular to watch. While we're getting set up and swapping presenters here, we have time for one question.
I'm wondering about type safety when using these micro frontends, especially if we are not on a monorepo setting and every team is working on their own repository. How do we make sure we are passing the correct props to these components that we're importing?
Yeah, this really could be a full-day workshop. I wanted to cover that. There's kind of two ways. So within a monorepo setup, you can supply a paths config to your tsconfig file that allows you to reference the alias that I used. But within a structure where each micro frontend is in its own repo, the module federation package actually supplies its own way to create a build that exports the types that you can then import within other repositories. So it's just kind of native to the module federation package that it supports multiple repos for using that kind of runtime micro frontend setup.
All right, thank you. One more round of applause for Matt.